Hello guys. In the previous video we managed to solve the Advent of Code 2024 Day 6 Part 1. And in this video I was thinking to continue to the Part 2. So without further ado, let's jump to the puzzle. Let's continue to Part 2. So just to recap, in the Part 1 we needed to figure out in how many distinct positions the card visited, and we did it by just using a simple dictionary to store all the visited positions, and we just calculated the keys how many we had there. But for the part 2, while the historians begin working around the card's patrol route, you borrow their fancy device and step outside of the lab. From the safety of the supply closet, you time travel through the last few months and record the nightly status of the lab's card post on the walls of the closet. Returning after what seems like only a few seconds to the historians, they explain that the card patrol area is simply too large for them to safely search the lab without getting caught. Fortunately, they are pretty sure that adding a single new obstruction won't cause the time paradox. They would like to place the new obstruction in such a way that the card will get stuck in a loop, maybe making the rest of the lab safe to search. To have the lowest chance of creating time paradox, the historians would like to know all of the possible positions of such obstruction. The new obstruction can't be placed at the card's starting position. The card is there right now and would notice. In the above example, there are only 6 different positions where new obstruction would cause the card to get stuck in a loop. The diagrams of these 6 situations use 0 to mark the new obstruction. Pipe to show a position where the card moves up and down, and then dash to show the positions where the card moves left, right, and plus to show positions where the card moves both up and down, left and right. Okay, option 1, but put a printing press next to the card's starting position. Okay, and then that would be also a loop, longer loop though. Or sorry, not a longer loop, but would take a bit longer. Okay, option 4, -1 corner, option 5, but okay, option 6, but thanks, okay. It doesn't really matter what you choose to use as an obstacle, so long as you and the historians can put it in the position without the cards noticing. The important thing is having enough options that you can find one that minimizes time paradox. And in this example, there are 6 different positions you could choose. You need to get the card stuck in a loop by adding a single new obstruction. How many different positions could you choose for this obstruction? How many different positions you... Okay, so we need to calculate how many times we can, or how many positions in our map there is where we can set this obstruction or obstacle so that we can cause a loop. Okay, maybe we could actually just convert or at the day 6 part. Oops. Day 6 part 2. Maybe not in written, but like that. So basically, let's clean these a bit up so that we don't have that much prints. And then if we run this, yes, we have the same. So maybe the first question is how to detect a loop. we could change this part 1 so that let's actually copy this. We can maybe utilize this like this a bit easier. So instead, I was thinking that instead of just setting every position to 1, we would actually increase this number. And then we would know what is the current max kind of maximum times of some specific position that is visited. And if we exceed that number, we know that we have a loop. That was kind of the first idea that came to my mind. So let's try that one. If not this, then do that, and then else we just increase. And we need to do the same thing here. Here as well. So now if we run this, we key error. Yes. And then none. Positions.get. And we can, or actually this none is optional, but we can have it there as well. Yes. And then if we run it, we get the same result. Good. So we didn't break anything. And then if we print this dictionary, we can see that there is multiple places visited. Nice. And then we could just get the max value out. And I'm wondering, did Max support the list format? Oh, it did. Okay. And let's confirm that it is indeed the case. So from here we should get the 76, and we get. Okay. So we know that the current max maybe visits is 3, and that's fine. And we could create new function that def rv is loop detected. We know that loop happens if there is at least one position visited, or technically actually it might not be enough to detect a loop, but we could try with this. So this is not the cleanest solution, but we can just do current max visits is smaller than max. And then return this, and actually let's say this to be positions, so that we are not overlapping or shadowing the variables. Okay, so we should be good with that. Actually, we maybe should move this above here. Because then we can gonna do it here. And so every time when we do this, we should check, is there a loop detected? And actually we need to maybe move this to here as well. Actually not here, but here. Now we can delete this one. And then we can clean these up as well. And I think we actually, if we manage to cause a loop, we won't end up here, because this happens when the card goes off the map. So we actually are interested in this bottom part, where we can say that if is loop detected. I have a typo, I think. I guess I misspelled it or something. So what we need to give here is the position. So basically the current visited positions. I don't know why it's giving that visited position. Maybe I used in the previous days or something. But if we have a loop detected, it means that we can increase our loop position count. And we can just throw it in loop position count. Okay. We can actually run it already like this, and we could in the end print that how many loop positions we have. We have 0 loops. That's wonderful. So everything is looking or working correctly. So what we need to do is that I was thinking that we could do this brute force kind of approach. I guess there is way better methods. But basically what I was thinking that we could just one by one add new obstacle every position in the map, and then kind of based on that run the code and see how it works. And if we have actually loop we want to break, because then we can use this while true, and for this outer loop, there will be a lot of loops for this. So basically for row in map and for position in row, we need to enumerate this actually. Wait, actually, I think we don't need to. Actually, better way would be use range from 0 to length of map, and then we could double check that one. What we get if we set list of range 0 to length of map. I think we need to use the +1. 129 and length of map is 130. So actually this would work. Yes, actually we are good with that. And then position in, I guess, row. Yep. We want to then check if row, see, map row. So basically this is row and then map row and then position. Maybe we can use row position. Is this or row equals y and row position equals x. So this is mandatory to limit the current position of the or not current position, but the initial position of the card off. And then we will do so that we want to run this in the loop. Yes, so we have two for loops and then while true in that. And for the map, I think we need to have from copy import copy. Yes, so we want to have the copy of the map every time we do this. So basically here we want to map copy equals copy map. And then what we want to do is map copy, and then we want to set the row and row position equals to this hashtag. And then we want to also actually copy this here. We want to add the map, current map. And we want to then give it parameter here, map copy. And then we want to make sure that we don't have any maps used here. No. Okay. And just for making sure we can run these one by one, and then we could Yes, visit positions is set. And we want to actually move this in here. Oops. In here. So that every time we start the new while true loop, so we start to check for the loops, we will reset the visited positions because that's important to keep up to date. Okay, so we could, I think, start running. Aha. What's that? Object of type int has no length. Oh, yes, of course. We need to get the row. And then I guess yeah, because now it's yeah. We want to do replace or not actually. We want to let's actually try. So if you have a string of ESD and then we split, yeah, strip. Let's actually Google a bit. Python replace character in string given position. Slice. Oh, yes, that could work. Let's try. So if we basically do, if you want to replace the character in position 3, it would be A, correct. So if you want to set that to be E instead, we could do E and then basically sorry, that is wrong. So it's this B and then we want to get B plus 1. I think. Let's see. Yes. ASD, ESD. So this will be interesting. So the row is actually the row position, and then we add it in, and then we'll just do like this. And that should work. Okay, it did run. but as we can see, without any success, so we didn't get any loops. So I'm wondering that if we just print the row, what we will see? We will see a lot of rows, but we can't. Let's then try using the map2, since we have that test case still existing. So we need to max visited position values. I'm now wondering that will this actually update itself, but yes, this will be rename this to be map instead, so we don't need to always do the same. So 41, that's correct. Then if we run this, we got current max visits off. Maybe we could actually add the print. So we have one. Each okay, that's not correct. Yeah, I think we need to run this instead. We could actually change this already so that it would the previous day, so that it would have this logic in. So yes, 41, and then if we do okay, then move the card, and then what does it say? Move card takes 3%, but 4 were given. One. That's not correct. Something is not aligning now. So what if we just add the it says that this is not a loop. Interesting. Let's modify this map so that we would have here, because then it should kind of stop here, go here, stop here, here. So it should be loop. A bit thinking that maybe my loop detection is not working as it should. Let's really copy this and run it separately here. We need to copy these as well. Yes. So if we run this loop, and then if we don't have that map 2, or this here, and we run this, it says loop. It prints the loop every time. Why it says that it's loop? Current max visits and the positions. I'm a bit interested. What? Okay. Why it's now 6? Because we have that 6. Yes. Okay. Okay. So we need to now run that. Then we can run this. Okay. I know why. We need to reset the variable, of course. Now it doesn't say anything. Now it's still 2, yes. Okay, and then if we add the thing here, it should say loop. No, it doesn't. Okay, that looks good. Oh. Yes. Okay, now we have a loop. So this should, okay, yes. So now we can delete, or not, let's not delete that one yet. But we should be able to run this. And it should tell us how many loops. There's 13. Not quite right, but better. So this map is the correct one. And we can see that if the second row goes all the way. Yeah, it goes. Okay. So something is off. This gives that one loop. Oh, let's remove that one. It could be that that kind of made it. Now we shouldn't have any loops, yes, okay, and now if we run it. Loop. 1. Why 1? So basically when we are in the situation where we have this, isn't it otherwise the kind of correct? Yes. Yeah, it looks good. Okay, interesting. I'm wondering, let's do this. No loop not found. And then we can, instead of breaking, to be like this, or maybe it's actually, let's not do that kind of naming, while not, and then one. We see that is loop detected. What we are kind of current max visits. It should be 2. Then if we do this, yeah, we add one parenthesis more. And we could actually remove, we are not, or maybe we could have those in as well, just in case. 2, 1, 2, 2, 2, loop. Ah, this could be definitely something that affects. Okay, now we start, I think, having let's see when we are in the and we have a loop. Yes, wonderful. So if you scroll to the bottom, we have 6 loops. And the example had, or not 6 loops, but 6 possibilities, options for the obstacles. Yes, okay. So we can delete that print. That's good. And now we can just run the correct map. Yes. And for that we can do these previous days runs. And now we can get the current max visits, which is 3, and then we can do that, and then we can run the move card, updated move card. And we should be ready to run this one. It will run a bit longer. Maybe I shouldn't have printed all of these values here, but instead just the result when it comes, since this will slow it down a lot. Let's actually do it so that I'll remove the print. Print from here, and instead of that we could just print the row so we can see where it's going currently. And I think that should be enough. I think there were 100 something rows, so let's wait a bit and see what is the result. I'll speed this part up so you don't need to wait. Okay, so we got result of 1902. Let's try it out. Your answer is too high. Okay, let's then think a bit what we could fix. I'm thinking that since we now just check that is the, oh no, we went to up. So the current max visits is 3. So what if we do something like that? Because now we kind of, if we even once go over something, some kind of already visited position, then we increase that position kind of visit count by 1, and then if it happens to increase them or exceed the max visits, then we are kind of maybe counting too many loops, even though they weren't loops. So if we do so that if the position is visited 3 times more than the current max visits, then we can say definitely that it's a loop, I would think at least. Again, a bit brute force way, but I think we should be fine with that. So if we start by just running this again, oh, it jumped. I'm wondering what did I do now wrong? Okay, we can just hard code that one to be 3, because we knew that why it started to run so fast. What change I did? I think we can clean this off. And then of course, stupid stupid mistake. Of course, there is so many more errors loops detect because of that. Yeah. Okay. Added the 3 in the wrong side. So now we should have again this slow running. Yes. And I'll do so that I'll speed this up so that you don't need to watch this slow progress. Okay, now we got the new result. So it's 1888. So a bit lower, 14 items or 14 loops lower than the previous value. Yes, nice. That was a bit trickier, definitely, this whole day 6 than the earlier days. But good that we managed to get the part 2 also solved. I think it's good time to pause it here. Thank you for following so long, and you enjoyed the video, and see you guys in the next video. See ya!